For problem 1, we need to figure out what the sum of all the internal angles are. Counting up the sides, we notice there are 4 sides. Using the formula n minus 2 times 180, because there will be n minus 2 triangles, we get 2 times 180, which is 360 degrees. Next, we're going to add up all the angles, which is x plus 1 plus 2x plus 3x plus x plus 2, and that's equal to 360. We combine like terms. There's 7 x's and plus 3, and that's going to equal 360. Then we're going to use SADMAP and subtract 3 from both sides, leaving us with 7x equals 357. Then by finishing SADMAP, we're going to do the opposite of multiplying by 7 and divide 7 by both sides, leaving us with x equals 51. Then we'll use that 51 and plug it back into the other equations. So A was x plus 2, so 51 plus 2. B was x plus 1, which is 51 plus 1. C was 2 times x, which is 2 times 51. And D was 3 times 51, which is 153. What is the measure of each interior angle of a regular decagon? We check our notes and find decagon means 10-sided, so tenagon. Using the sum of the interior angles of a polygon, we know that is n minus 2 times 180, or 10 minus 2 times 180. That'd be 8 times 180, which is 1,440. We then remember that we have 10 sides, so we're going to take the 1,440 and divide it by 10. So 144 degrees is the measure of each interior angle of a regular decagon. Problem number 3, we need to figure out how many sides a regular polygon has if the interior angle is 156 degrees. So we take the formula for the number of sides, n minus 2 times 180, and divide it by the number of sides, n, and set that equal to 156. Don't like fractions, so I multiply both sides by n to get rid of the fraction. To get rid of the parentheses, I distribute the 180 over n minus 2. Then I'm going to subtract 180n from both sides, which leaves me with negative 360 equals negative 24n. Divide both sides by negative 24, I get n is equal to 15, and that's the number of sides of a regular polygon that has an interior angle of 156 degrees. The difference between problem 4 and problem 3 is this one says exterior angles instead of interior angles. So we have an exterior angle that measures 18 degrees. The measure of the sum of all polygons for exterior angles is 360 degrees. We're going to divide that by n and figure out when that's equal to 18. We're going to get rid of the fraction by multiplying by n. We're going to get n by itself by dividing both sides by 18. Punching that into a calculator, I get n is equal to 20, which means the answer is 20. Problem 5 looks pretty big, but there's not a lot of math. The measure of angle n is based off the measure of angle p. Since both those angles have to add up to 180, 180 minus the 35 gives you 145 degrees. In a parallelogram, opposite angles are equal. So if one angle is 37, the opposite angle is 37. So the measurement of angle m is 37. Remember, parallelograms have not only parallel sides, but equal sides. So 32 on one side equals 32 on the other. For OP, ditto. Diagonals of a parallelogram bisect each other, so 30 is equal to 2x minus 4. Add 4 to both sides, divide by 2, and that gives us x equals 17. The other diagonal is also bisected, so 3y equals 15. Divide both sides by 3, and you get y equals 5. Here are a few properties of rectangles. Look in the bottom left corner, it's 50 degrees. That means that the angle opposite it on the opposite corner on the inside will also be 50 degrees. For the red angle, since the angles of a triangle are 90 degrees and the one is 50, that means the remaining angle is 40. Opposite sides of a rectangle are equal, so 86. Repeat, opposite angles of a rectangle are equal, so 72. Now let's look at the gold angle. Now, we know that the blue angle up there is 50. The one on the opposite side of it is 50. A triangle is 180. So 180 minus 50 is 80 degrees. Now for the light blue angle, since we know that the gold angle is 80, and the light blue and the gold angle add up to 180, so 180 minus 80 is 100 degrees. AE is half a diagonal. We know that half a diagonal, which is EB, is equal to 56 degrees. That means AE is also 56 degrees. DB is a full diagonal. We know a half diagonal is 56, so another half diagonal is 56, and 56 plus 56 is 112. Now we're going to deal with properties of the rhombus. Since all the sides of a rhombus are equal, DC is also 30. AD, also 30. BE is half the diagonal BD, so half of 25 is 12.5. The diagonals of a rhombus form a 90-degree angle, so BEC, 90 degrees. Measurement of angle ABE is, let's wait on that one. Measure of angle ABC, let's wait on that one too. Problem 8, a lot of properties about trapezoids. Using midpoint segments, we know that the middle segment is halfway between the top segment and the bottom segment. So the distance is 7, so 7 more than 17 is 24. Consecutive non-base angles of a trapezoid add up to 180 degrees. So since the bottom one is 50, 180 minus 50 is 130. Using that same rule on the other side, 180 minus 60 is 120. Since this is not an isosceles trapezoid, none of the angles have to be equal. Since HK is the midsegment, that means the value is halfway between 17 and 10. Add them together, divide by 2, we get 13.5. Non-consecutive base angles add up to 180 degrees, so we have 180 minus 28, which is 152. But the second trapezoid is said to be isosceles, so if the orange angle is 152, that means the pink angle is 152. And the light blue angle matches up with the angle on the other side, which is 28 degrees, and we've now finished this review.